With our conversation around probability, um, we want to look at some maybe more interesting examples than just flipping a coin. So, a lot of historians of probability in science root the history of, or the origins of probability in games, humans playing games. So, this is a very old game called the Game of Senet. It's dated to at least 3000 BC, Egypt. Had two kinds of pieces to move on a little board, and your moves were determined by dropping four two-sided sticks. So how many places you could move and where you could move were determined by the outcome of dropping these four sticks. So that's what we want to start exploring a little bit here. Now, this table represents the different ways that those four sticks could fall. So here is this for four sticks. There's a few different outcomes, right? We could get no whites, one white, two white, three white, four white. If we consider the sticks as like, I don't know, white and red, white and black, whatever. So, but we can also think about an even simpler case, right? If we just have one stick here and we drop it, there's only two outcomes. It's either going to be white or red. If we have two sticks, there's actually four possible outcomes. Stick one could end up white, and stick two could end up white. Stick one could end up white and two red. Stick one could be red and two white, and lastly, they could both be red. So we've got to be careful when we start repeating events about counting possible. It's not just one, they're not all equally likely. And similarly with three, right, there are three ways to get one white. We could have red, white, white. We could have white, red, white. And we could have white, white, red. And so on and so on. So here are all of the different ways that we could get or the different outcomes that we could have if we drop four two-sided sticks. So notice that each of them have different probabilities. And this is a very important next step in probability, is that we actually have to, like if we repeat a Bernoulli trial, or we repeat one of these things that has two outcomes, right? That's all that one of these sticks is like flipping a coin. But now we have a combination of them. There's two, we're flipping two coins at once, or dropping two sticks at once. And when we do this, we have a special name for this also. It's called binomials. And the function that we can say, okay, we're interested in this outcome this many times where it has this probability, is a binomial distribution. And this is what the function looks like. It's a little bit messy, but we'll unpack this. All right. The big idea is that we're putting into it, much like our Bernoulli example, this is a success or failure, all right? A 0 or a 1. This is how many of those we're interested in happening. And this is the probability of a success. All right, and this is the more normal way to see that. What this piece does is counts how many ways there are for the outcome to occur. It's called a combination. This is the probability of the success, and this is the probability of the failure, and this is how many times those exponents are, how many times each of those we want to occur. So for example, if we're talking about getting two sticks out of the four being white, we would say that means from these four, we're choosing two. The probability of success is 1/2. We want that to happen twice. And then 1 minus 1/2 is going to happen the other two times. All right, and we'll use a computer usually to compute these, but we already know what this is. This is 6, right? So we would have 6 times 1/2 squared times 1/2 squared. All right, and that's the idea. Now, most of the time, we'll abstract this away to the computer and use the computer to find that. And this is how we can do that. We have a combination function from SciPy that we can use here. So there's 6 ways to choose 2 things from 4. Again, the probability of success would be this 1/2 squared. Probability of failure is everything else, the 1/2 squared. And then if we put it all together, we take the combination, we multiply it by the probability of success times the probability of the failures. We get the probability of that total outcome. Okay? So the probability of getting 2 white out of those 4 sticks would be 0.375. All right, and what it involves is counting how many ways there are for that to happen, probability to the power of the times that we want that success, and then here's everything else. Multiply it all together. Okay, so I want you to use those ideas to think about these problems. How do we, if we played the game of Senate with 5 sticks, right, fill in that other row of the table and answer these questions. How many ways are there to get 3 white sticks? What's the probability that we would get 3 white sticks? Suppose we toss 10 coins. How many different outcomes contain exactly 3 heads, right? 10 choose 3. What if it were 20? What's 20 choose 3? And then finally, fill in the next 2 rows for that game of Senate. What if we had 5 sticks? What if we had 6 sticks? And look for a pattern in that table.